Hey everybody, today what we're going to be looking at is substitution method for solving systems of equations. So previously what we looked at is when we graphed two lines, we saw where they intersected. And we found out this point was the point of intersection, and that was our answer. Today we're going to be doing something a little different, where we're going to substitute it and solve it algebraically without the use of graphs. So let's go ahead and take a look at this first example. Now, whenever we use this method of substitution, what we want to do is look at one of the two equations and see which one has a variable that's all by itself or that's easy to get it all by itself. This first example is not too bad because we already have an example where we have a variable all by itself. In this example, we know what a equals. A is equal to negative 4b. So what I do now is I look down at this example and I see, do I see an a anywhere? And I do, I see 3a. Now I know what that 1a equals because 1a equals negative 4b. So I'm just going to plug in that negative 4b in for that a. So I still have 3 parentheses, and instead of that a, I'm going to write negative 4b plus 2b equals 20. I want you to notice when I look at my new equation now, there is no a values. There's only one variable, which is a positive b. So now when I solve for this, I'm going to distribute to get negative 12b plus 2b is equal to 20. I'm going to combine my like terms to get negative 10b is equal to positive 20. And when I divide both sides by negative 10, I'm going to get b is equal to negative 2. Therefore, with my two variables, I already know what one of them is. So what I'm going to do now is I'm going to look at my original two equations, and I'm going to say, when I plug in, instead of b, I'm going to plug in negative 2, which one will it be easier to solve for a? In my opinion, it's easier to plug it in the first one. So I'm going to have a equals negative 4b, but instead of b, I already know what b equals. It's negative 2. So when I solve this, I'm going to have negative 4 times negative 2, which is positive 8. And that is my final answer. Now in an ordered pair, it always goes ABC order, so it's going to be 8, negative 2. Now, some people might say, what if I plugged in negative 2 to this equation? Would I get the same answer? And the answer is yes. So this would look like 3a plus 2 times negative 2 is equal to 20. This would give me 3a plus a negative 4 is equal to 20. I would add 4 on both sides to get 3a is equal to positive 24. And when I divide both sides by 3, we still get a is equal to positive 8. So it doesn't matter which one I plugged it into. All right, so let's go ahead and look at this next example. This next example, I have x equals 1/2 x plus 3 and 2x minus y equals 6. Now, it's easier to plug in. I have x equals 1/2 y plus 3. So that's pretty, I don't need to get x all by itself because it is already by itself. So I look at my second equation and say, do I have an x value where I can plug in 1/2 y plus 3? And I do. It's right here. So what I'm going to do is every time I see an x, I'm going to plug in what x equals, which is 1/2 y plus 3. So on the second equation, I'm going to have 2 times x, and like I said, instead of x, I'm going to plug in 1/2 y plus 3. Minus y is equal to 6. When I distribute this, I'm going to have y plus 6 minus y is equal to 6. I'm going to combine like terms to get y minus y is 0. They just cancel, and I'm left with 6 equals 6. Now, anytime when you solve a system and you have an answer where they both equal each other like this, this is infinitely many solutions. And what this is essentially saying is if I were to graph this, they would be the exact same line. It would just be one line on top of each other. So if I looked at this highlighted blue line and this red line, I say, where do they intersect? Well, they intersect everywhere. Every one of these points, they intersect because it's the same line. Therefore, it's infinitely many solutions. All right, so let's go ahead and look at this one now. I need to try to get y all by, one of the variables all by itself. So you want to look at your top and your bottom equation and think, which one is it easier to solve for? Is it easier to get x by itself or y by itself? Or if I look at the second one, is it easier to get x or y by itself? In my personal opinion, I would choose the top equation, and since x does not have a coefficient, I would try to get x by itself. So if I have x plus 14y equals 84, the quickest thing to do is just subtract 14y on both sides to get x is equal to negative 14y plus 84. So then when I look at the second equation, I look for the variable x, and I know what x equals. X equals negative 14y plus 84. So I'm just going to plug that in there. So this will be 2 times the quantity of negative 14y plus 84 minus 7y equals negative 7. So remember, I plugged in negative 14y plus 84 because that's what, there was an x there, and that is what x is equal to. So now when I solve, I just distribute to get negative 28y plus 168 minus 7y is equal to negative 7. So then when I solve this, then I'm going to combine like terms to get negative 35y plus 168 is equal to negative 7. So I'm going to subtract 168 on both sides, and this will give me now, I'll write it in blue, negative 35y is equal to negative 175. And all I do now to get y by itself is divide both sides by negative 35. And a negative divided by a negative is a positive. And 175 divided by 35, let's go and do that together. 175 divided by 35 is equal to 5. That means my y variable is positive 5. Now I solve for my y variable, and now all I need to do is solve for my x variable. So you look at these two original equations. I'm going to erase a little bit to make it a little cleaner to see. And you choose one of them. It doesn't matter which one. And you're going to plug in, instead of y, you're going to plug in 5, and you're going to solve for x. You can plug it into either one. In my personal opinion, the top one looks a little easier to solve. So in purple, I'm going to go ahead and write that down of x plus 14. And instead of y, I know what y equals now. It's 5. And now all we're going to do is solve for, we are going to solve for x. So it's going to be x plus 14 times 5 is 70 is equal to 84. And let me just confirm my math is correct there. 14 times 5 is 70. Okay. So I'm going to minus 70 on both sides to get x is equal to 14. And then I'm done. So the point of intersection between these two linear equations is 14, 5. All right, now let's go ahead and look at this one. This one's a special, kind of a special case. It's a unique case scenario. I want you guys to notice that I have y equals on both of them and y is all by itself. When that happens, all you do is set the two equations equal to each other. So it'll be 3 over 4x minus 1/2 is equal to negative 5 over 6x plus 8 over 3. Now you have a bunch of fractions here. So what I would do is do a fraction buster, or clearing the fraction. When you look at all your denominators and you see what can you multiply each and every term by, that would eliminate all your denominators. And that would be 12. So there's a few ways to do this. You can either divide first and then multiply across, or you can multiply first and then divide. I'm going to multiply first and then divide on all of these. This will be 36 over 4x minus 12 over 2 is equal to negative 60 over 6x plus, let's see, 8 times 12, 80. So that would be 96 over 3. So then I just simplify this. This would give me then 12x, that would give me 9x minus 6 is equal to negative 10x plus 32. All right, so then from here I would add 6 on both sides, and I would add 10x on both sides. This would then give me 19x is equal to 38. And when I divide both sides by 19, I would get x is equal to 2. That's awesome. So now what I can do is I can plug into any one of these equations. So I want you to think about it. Would it be easier to plug in x equals 2 into one of these original equations, or would it be easier to plug it in to one of these two equations? In my personal opinion, I would choose one of these two equations. So let me show you how I would do that. Essentially what I would do is I would find one of these equations, and we can do y equals 3/4 x minus 1/2, and I'm going to do a fraction buster to that. So y equals 3/4x minus 1/2. If I multiplied each and every term by 4, this would give me 4y is equal to 3x minus 2. And I'm going to plug in x into this equation now. 2 in for x. So this will give me 4y is equal to 3 times 2 minus 2. This would give me then 4y equals 6 minus 2, which would be 4y is equal to 4. And when I divide both sides by 4, I'm going to get y is equal to 1. Therefore, then, the point of intersection of these two lines would be 2, 1. Alright guys, I hope this video helped. If you have any more questions, please feel free to email me or your teacher.